So for the Excel file for this assignment, there are 4 tabs. The first tab only needs to include your name and your ID, which is the simplest, but you need to make it look nicer than this. And the second tab would include the original data from the case, as well as the slope and intercept that you calculated, which is question 2. So the difference between this one and the videos that I posted previously is that I think the professor wants you to have nice formulas, which means that your formula should only include things like dP over P, which is percent change in P over percent change in Q, multiplied by current price, divided by current quantity. And by the way, this is the right formula. The one I did previously is incorrect. And similarly, the intercept should have a formula like this, which is current price minus slope multiplied by quantity. So the way to make this thing work is by selecting the whole table. So if you select this table, and then you go to formulas, and then you use create from selection. And remember the difference between the name tag that I showed you in the previous video is that I checked left column there, but now you check top row. So if you check top row, then each one of these symbols will be defined as a vector. So if you go to the name manager, you probably see that A is defined as a vector. So if you increase it, it's a vector of different numbers. So it's not a single number anymore. So it's a vector. That would be why if you type in say PC and QC here and here and here, note that the formulas are exactly the same, but the numbers are different because they are vectors. So if you start with this and you drag down, then every number will be consecutive numbers in that vector so that you can create a row with entirely the same formula, exact same formula, but with different numbers. So the other things that you need as a parameters are probably DPP is percent change in price, DQQ is percent change in quantity. But again, since I don't want to type too much, so probably you want the symbol to be longer, so you may want to actually type in percent change in quantity, and because that could be nicer. And remember, one thing you need as a parameter is the number of ships. So the professor said that he may change the numbers, some of the parameters, to see if your program still works. So you might want to include some parameters like this. You don't need to include a parameter like the season because that's making this Excel file a lot more complicated than needed. But like say the number of ships, you may want to include it. And for question 3, which is the first optimization problem, there are only 4 rows that you need to, 4 columns you need to include. The first one, you could leave them as empty. So start with empty things and check the price. It's just A plus B multiplied by UQO, and UQO here is the unconstrained quantity optimized. So note that the A and B are defined in the previous tab, but it can still be used here. And yes, I'm just telling you that you can actually use things, the name tags that are defined in different tabs, and so that each one of them are still the same, but the numbers are different. Revenue is just UQO, unconstrained quantity multiplied by unconstrained price multiplied by N. N, remember, is number of ships. And elasticity, this time the formula is right. It's 1 over slope. Last time I did it slope, just slope, but you should use 1 over slope multiplied by P divided by Q. So after you have all this, then you calculate this total revenue. So I assigned it to a symbol as well to make the solver easier. But this you can just write sum of this vector, because again, when you assign name tag to a column, it becomes a vector. So you just sum that vector basically. And now the solver thing, you go to data and you click solver. And here, remember, you only need to type in the name of the symbol that you assigned. So UTR is the unconstrained total revenue. And by changing UQO, not he, but Excel automatically knows that you want to change this entire column, this entire vector, not only one number. And when you click solve, hopefully you get something, and then click OK. Then the way to check this is checking whether elasticity is -1 or not. And if it's -1, it shows that everything you've done here is correct. So the number should be positive. It should not be negative. It should be like 6 to 7 digits. Okay, it's not too large. There is actually this elasticity way of checking this, but for the next one, there's actually no way of checking whether it's right or not. So make sure that it's right when you submit it. And the first 3 columns are exactly the same, so I will not repeat it. Here I added the if condition because sometimes when you optimize, you get zeros in some of the countries, which is actually possible for some of the IDs. And a way to explain it in your report is that those countries are inefficient because of something. You can explain because of they are putting the weights inefficiently, or they are allocating the ratios inefficiently or something like that. But if they are 0, you don't want an arrow saying like divided by 0 arrow. You don't want that. So what I did is if it's 0, I put it to minus infinity. And so, for example, if I actually delete everything, it gets minus infinity here instead of putting like divide by 0 arrow. And here is the number of 20-foot containers. So the formula, I will probably not derive the formula again, but you can just look at it and see why it's right. So it's the total quantity multiplied by the percentage of the quantity that is 20-foot containers. So this is just RT. If you go back to Q2, you see that RT here is the ratio of like the 20-foot, and RF is the ratio of 40-foot. So it's, for example, 30 to 70. And go back here, it's just, this is like QO multiplied by 0.3 here, and QO multiplied by 0.7 here. Note that the reason I divide by 2 is each 40-foot container has 2 TEUs. So TEU is a unit for volume, so 40 is twice 20-foot container. The size is twice, it's, I think you understand what that means anyway, so I'll go to this weight of 20-foot one. So this is number of 20, so NT is this column, and this UWT, if you go back here, UWT is the weight per unit weight of 20-foot container. So if you multiply them, it gets you the total weight. So this column WT is actually the total weight. And similarly, this is the total weight of 40-foot containers. And there are a lot more things to compute here, obviously. And this total revenue here is just the sum of the revenues. Total weight is the sum of weight of 20 and weight of 40. And total TEU is similar, it's just the sum of the total quantity, because quantity is in terms of TEU. So if you sum them, it works. And the ratio here is the sum of 40-foot divided by the sum of 20-foot, which there was a typo in the case, which says the ratio should be 20 to 40, but now we want to change it, we want to 40 to 20, so that's why it's 40 on the top and 20 on the bottom. But the reason that there is a 2 multiplied by, I think it's obvious as well, because each 40-foot container contains 2 TEU. I mean, not contains, but it has a volume of 2 TEUs. So you multiply by 2 to convert the number, since NF is the number, and you multiply by 2 to get the TEUs, and then that's the ratio. And the ratio of the numbers is just this ratio without multiplying by 2. So another thing that I ignored last time, but the professor actually wants you to do is, he wants you to show the calculation of how the maximum weight or maximum TEU is computed. So without the condition on high season and low season, it's actually 24,000 and 2,000. But with the high season and low season conditions, there is actually a certain percentage of it that can be used. So that's why the formula here is, if the season is high, it's the maximum weight multiplied by, if it's high season, what's the percentage allowable weight. So it's basically this number multiplied by 95% divided by 100. And similarly, the TEU constraint should be constructed in the same way. So the max amount of TEU multiplied by the percentage that can be used during high season, either high season or low season. But the mean and max ratio is always 1.2 to 2, so you don't need to change that or anything. So after you have this table, then it becomes very easy to do the maximization. So go to solver, type in the thing that I have here. So objective is total revenue, and this by changing still QO, we want to do it this way. Last time I said you may want to do it by changing the number of the containers, but the professor said that it's actually better to do it using either quantity or price. So either quantity or price is okay, but don't use the numbers. And the professor specifically said that do not add the integer constraint. So last time I said integer constraint, but he said no integer constraint. And he's making the solution, so listen to him. So don't include the integer constraint. And the for constraint you want is the total ratio. This is not Toronto. This is total ratio is smaller or equal to the max ratio, greater or equal to the mean ratio. And the total TEU is smaller or equal to the TEU constraint, and total weight is smaller or equal to the weight constraint. So after you have all of this, you click solve, then, well, seems I get an error here. It takes some time to fix this error. Maybe starting with some value might be a good choice. I don't see if it works. Click solve. Okay. So I was not planning to show you that, but it happened by accident. So you know that sometimes if you start with wrong initial values, you may actually get this solver not solvable. So that's actually a problem with the solver. So the way that solver does this is it starts at the numbers that was specified here, and then it it goes around it to see if going which direction there is a higher number, so it jumps to that direction. So the starting value actually matters. So you probably did see that last time when I start with 0, it shows that there's no solution. But if I start with 100, it shows there is solution. So sometimes if you click solver and it shows something like there's no solution, you probably want to change your initial condition to something like more reasonable, like say 100 here, or if you want, you can change it according to the previous answer. So you basically copy and paste these things here, starting with those, and then click solver. That may help if you couldn't find a solver initially. So I think that's about all you need. So good luck on this project, and good luck with your business report.